Good morning friends, welcome back to my YouTube channel. So today I will explain the numerical based on the V connection or open delta connection. So numerical is a 3-phase 1000 kVA 0.86 lagging power factor load is supplied by a V connection at 400 volts. Determine the kVA output and operating power factor of each transformer. Neglect the exciting current and all losses. So SL is given, load kVA is given equal to 1000 at an angle cos inverse 0.86. So you can write 1000 at an angle 30.00, or you can say this load apparent power equal to √3 VI. So compare both the side, compare the magnitude, you will get √3 VI equal to 1000. So you can write VI equal to 1000 by √3. SL equal to this load kVA supplied by the two transformer of the open delta connection SA and SC. So SA equal to VI 30 minus 5. I already have explained this thing SA and SC, how I calculated. So you can just go through that lecture. I will provide you the link of that lecture. So S equal to VI at an angle 30 minus phi. Phi is 30 degree and SC equal to VI 30 plus phi. So 1000 VI is 1000 by √3 from this relation. So 30 minus phi is 0. So transformer A is operating at the unity power factor. Cos 0 is 1. So it is operating at unity power factor. And the transformer C equal to VI 30 plus 5, VI is 1000 by √3 at an angle 30 plus 30, 60 degree. So this is basically 577. So this is 1000 by √3, 30 plus 30, 60 degree. So it is 577.35 at an angle 60 degree. So power factor is cos 60 equal to 0.5 lagging power factor. So transformer is operating at the unity power factor and transformer C is operating at the 0.5 lagging power factor. So if you like this video, thank you for watching.